Good evening. My name is Harry Helling. I'm the Executive Director here at the Birch Aquarium at Scripps. I would like to welcome you all to the Jeffrey B. Graham Perspectives on Ocean Science lecture. It is my great pleasure to introduce our speaker this evening, Dr. Neal Driscoll. The topic that we're exploring tonight is really kind of diverse, and you'll see we're going to connect two broad topics together. So given the recent devastation caused by the North Bay wildfires, researchers from the University of Nevada, Reno, and UC San Diego are working to rethink our approach to fire response in California and throughout the West. Thus, the talk for this evening, Early Detection Fire Camera Systems Prove Their Worth. Dr. Neal Driscoll is a professor of geosciences research in the Geosciences Research Division here at Scripps Institution of Oceanography, UC San Diego. Neal obtained his PhD from Columbia University in geology and geophysics. He's worked at Columbia University and Woods Hole Oceanographic as a research scientist. His primary interest is in tectonic deformation, specifically fault segmentation and interaction. And one area of his research he has focused particularly on is fault activity and recurrence intervals. He's published over 100 peer-reviewed articles in top journals. As well, I've noted, this wasn't in my written script, but I added this because I think it was left off of the intro that was given to me. Neal does such amazing work across an entire spectrum of applied projects, some of the ones that I know about. You may have seen some articles last fall. His team discovered a major fault that runs right underneath the Salton Sea that became pretty big news. Or perhaps you're following the California high-speed rail. So he's the what he represents on that project is the study of the tectonic security or safety of the planning for that project. Or finally, perhaps you've heard of SONGS, the San Onofre Nuclear Generating Station. So in this effort to take down that or deactivate that site, somebody has to assess the safe storage relative to plate tectonics and the movement to that space. And Neal's group has been hired to do that. So you can see this work is both helping us to understand the planet and also helping us to understand how we fit into the planet. So without further ado, I'd like to welcome Dr. Neal Driscoll for Early Detection Fire Camera Systems Prove Their Worth.
So you're probably saying, here's an oceanographer, a geophysicist, a geologist. What's he doing with early detection fire cameras? These camera systems and networks are hung on microwaves that are resilient and won't go down like cell phone technology. So the thing I'm going to conclude with is these aren't just early fire detection. These are multi-hazard networks that provide us early warning for earthquakes, floods, atmospheric rivers, and fires. Okay? We live in hazard country, and we need to do everything to give us early warning so we can be prepared. So every project has great people involved when it's successful. And I'd like to acknowledge Graham Kent and Ken Smith from the Seismological Lab at the University of Nevada, Reno. They have spearheaded this second part of this project that has brought us leaps and bounds further in our technology and imaging capability. I'd also like to acknowledge Frank Vernon, who had a vision back in 2000 to bring data and information from the backcountry into command areas where we can use this information to make decisions, marshal resources, and protect our people. I'm only on this list because I'm up here talking to you today. I'd like to also acknowledge our collaborators and supporters. San Diego Gas and Electric is ahead of the game in monitoring the backcountry and fires. They have a command center that's second to none. It's almost like being in NASA at JPL, which I've been in both, and they're very impressive. And they collaborated with us to put these cameras in, and these cameras provide everyone early warning so we're never caught off guard by fires. So specifically, Carolyn Wynn was a champion of this project and made it happen within a week. We were there on a Thursday afternoon, and they provided the funds the following week to build out this camera network. So thank you very much, SDG&E. So as I said, California is hazard country. We all live here because it's beautiful. We live here because the ocean and the mountains. We live here because we are progressive and we respect diversity and we respect the environment. We are California. But we do have earthquakes, and here's some of the 3 largest in the history of California, all just under about an 8. So we do have this risk. We're far from the San Andreas, but we have our own fault system right offshore called the Rose Canyon Newport Englewood. And research we've performed has shown that this could, all the segments could rupture together in a magnitude 7.2 to 7.4, which will be a significant event with much shaking. We can talk about earthquake preparedness on another time, but tonight we're going to look at fires. The Cedar Fire in 2003 was our first experience with such a fire like this, and it caught us off guard. It jumped all the lanes of the 15 highway at Miramar, something we never thought a fire could do. So we had the perfect storm. We had low humidity, single digits, we had high winds, and we had fuel. You put those together, and it's a firestorm. We also have landslides. This is the La Conchita 2005 landslide, killed 10 people. This landslide's sitting right here, okay? So we have landslides. We also have the risk of offshore tsunamis. So as I said, we live in the land of hazards. But I think our governor said it best. These fires are the new normal. We need to better equip ourselves and our arsenal to detect early, marshal resources, and make informed decisions and have situational awareness of the safety of our first responders. These cameras will help. They're not the whole answer, but they will help. So this network here employs high definition 4K pan, tilt, zoom cameras with near infrared. We can detect smoke during the day and we can detect heat at night. Okay, so during the day we have from each camera about 50 to 60 mile range. And we're working with San Diego Fire, the Monte Vista Command Center. They have access to the cameras so they can zoom and look for fires, especially during red flag, and now we have purple flag fire hazards. So also, we can capture the early ignition so we can make better informed decisions, and it improves our situational awareness. So as these first responders are going into the field, they can see the cameras on their tablets. They can see the color of the smoke. They can see if the smoke is bent over and windy. We can put this into models of fire. So all of this builds together. So this is the Wildfire. This is July 7th. We repurposed the Oroville Dam Cam. And here you can see the cyclonic activity. This was one of the first times that we actually captured the dynamics that fire, and it starts its own weather. And we can input this into models and we can better understand fire dynamics, especially with fuels and topography. So this here was in Oroville, California, picked up on one of our repurposed cameras. So here, with this new alert SDG&E, you can go on to Alert Wildfire, and you can look at all these cameras. You can assess where you are with respect to fires, and you can have early detection. So here, Carolyn Wynn, I just want to read a few quotes. Adding this sophisticated set of cameras is providing us with a level of real-time situational awareness we've never had before. Not only are we able to zoom in on ignition points using multiple cameras, we can pinpoint almost instant fire proximity and notify first responders, okay? These are game changers. They're providing information. So here, this was the church fire. This was one day before a red flag warning went up with strong Santa Ana winds. This out by Campo. And here, Chief Brian Fennessy, the safety of my firefighters and the communities they protect is my priority. So having more information about a fire before we encounter it is an added safety measure that benefits our first responders. Having access to a live view of our highest fire risk areas will greatly improve situational awareness, our coordination with CAL FIRE, and allow for quicker response times, better response strategies, and faster evacuation orders to ensure our communities are better prepared in the face of wildfire. So here, Brian said he could look at this fire on his iPhone and determine the color of the smoke, whether it was bent over, how many engines he'd have to send out, how could he marshal his resources, when would they come back to protect the rest of the county he's responsible for. So let's here look on our cameras and look at the ignition or start. So we caught this fire early on. There it is. Okay, so we caught the church fire early on. You can see that it's windy, the smoke is bent over, picking it up on this third camera. So by having it in 3 of our cameras, we can triangulate and give coordinates to first responders. We also catch the fire early enough that suppressing it is easier. So here, our chancellor, Pradeep Khosla, said, understanding and protecting the planet is one of UC San Diego's core research themes, and collaboration like this that improve technology to respond to hazards impacting our state are a great example of what's possible. This new upgraded camera network will be a resource for the public and those working to protect the public for years to come. So this is one of the main themes. We are the University of California. You don't have to say anything else. They know that's San Diego. So here, this is what the cameras look like. So this is the Axis pan, tilt, zoom cameras, near infrared. This is the microwave technology. So we have licensed frequencies where no one else can step on us. In an emergency, cell phone coverage will go down. Our network is resilient and will stay up and provide that early warning. We've proven it. We're able to take large amounts of information from the backcountry and bring it to command centers to make informed decisions. The amount of data that we need to take for early earthquake is a fraction of what we're already demonstrating. We have built a resilient system that's going to provide early warning for Californians. Here's where the batteries and electronics are housed. So with the solar panels, these are standalone, okay? And they provide us information. We can put moisture sensors on them, weather stations, seismometers. All right, so we can build out this network, and we hope to have California built out in the next 5 to 6 years. I'd like to give you a little history, because some of you might have heard the term HPREN, okay, the High Performance Wireless Research and Education Network. Frank Vernon and others here had this incredible vision of how we could bring high-speed data back from the backcountry for experiments, research, fires. But when they built this in 2000, they were looking at 45 megabits per second, and now we're up to 220 to 500 megabits per second. I don't know if you saw in the papers, but the Board of Supervisors for San Diego County have just approved funding to upgrade this network and put in 5 more cameras. We need coverage to make sure that we don't have blind spots in the camera network. So here, if you go on, we've morphed into AlertWildfire.org. This is a map showing all the cameras. This is the camera being used right here. You can see the insonification or the blue pattern showing which way the camera's looking. And if you look out here, you can see Big Laguna Lake out here towards the east, and we can zoom in. So we have this kind of coverage, so we can detect fires when there's first ignition, okay? So here, just look at the difference in resolution, from here, looking out this way, to here, okay? So these high definition cameras are incredible for detecting early ignition. Lightning strikes up north in Tahoe have been detected using these systems because lightning strikes stay hot for hours, days, and then can ignite. We also have time lapse. So this time lapse allows us to go back in the camera's history and look at the fire development. And the reason this is really important is we can then put this into models or help constrain models of fire development. So the San Diego Supercomputer Center is doing an amazing job at modeling fires, looking at fuels, topography, weather, okay, humidity, and putting all of this into a burn model so that we can understand where fires are going to go. So here, this was the Emerald Fire, and what you're going to see is when I play this, this is the fire pattern. The colors change through time, and you'll see a gray zone underneath, which was the actual burn pattern. So let's look at this and see how well they did. So here, there's the burn pattern, and there's the hindcast. So I'm cycling through this. So you can see they did a really good job at capturing the burn pattern given the weather, fuel. So now I'm going to change it. So here you'll notice there's more detail. I used satellite to define the burn pattern better. And now I'm going to go look at fuels. Okay, so here, these are all the different fuels that are being burnt in a fire and govern how hot the fire is going to be. I'm going to show you a slide of stands of dead trees in the Sierras, and this woody material burns hotter. And so we want to know the fuels, we want to know the amount of fuels. Last year, the rainfall increased the grasslands, and we were all very concerned about a big fire year, and 2017 was just that, a big fire year. So here, I took this picture yesterday afternoon, and I love rain. Okay, every time it rains, I smile. So driving in today, even though everybody's going like 90 and tailgating in the rain, scary roads here when it rains. Thank goodness it doesn't snow in San Diego. But the moisture, this is a camera up on Palomar, and you're seeing the moisture move in, okay? So these are the cameras that you can click on all around the county, and they're shown here. So you can go and look at the real estate, especially in a fire, because the command center will have these focused on the fires. You can understand where it is with respect to yourself, because you can blow this up and the detail is down to road level. You can see your own road. So here, we used to have 16 cameras. We had a little incident here at Black Mountain, so this is what it looked like. And then this is what it looked like after the big windstorm a few weeks back, where peak winds were like 90 miles an hour. All right, so we have some repair work. But that's part of the business here and working in the backcountry. So Black Mountain's down, and we're hoping to get it back up in the next week or so. So here, you can also shrink the area being imaged by the camera so you can get higher resolution. This was a controlled burn. So we called this in minutes after we detected it, and we were informed by Monte Vista dispatch that this was a controlled and approved burn. But you can see how important this is to grab these early, okay? Early detection. We have a much better chance of fire suppression and making informed decisions when we catch these early. This was another fire here that we caught towards the end of November, okay, and we were able to put that out quickly, okay? So these cameras can bring the data back from the backcountry, and they can inform us. So here, what we do is we take different cameras and put it on the fire, and we can triangulate, and we can know exactly where the fire is, so we can transmit that information to San Diego Fire, CAL FIRE, Cal OES, and then they can respond and marshal their resources accordingly. Here's the near infrared. So the near infrared sees about 120 miles. The daytime cameras see about 60. So this was here. We're looking at the cameras. We don't know how far this is away. We don't know whether it's on our side of the border or on our neighbor's side of the border. And we're collaborating with them so that they have access to these cameras, and we're trying to build a frequency so we can talk across the border. But these fires turned out to be down by Rosarito. But we were looking at these, and Graham Kent, my colleague, and I, we were on the phone, and I'm there, they look really big. And we couldn't tell at first where they were, and we were deceived by how bright they were, but then by triangulating these cameras, we could gain confidence of where the fires are. So here, the red flag warning on 12/8, all right, we had 370 gigabytes per day downloaded. So this system is resilient, it didn't crash, and we want to build it out so that people can hop on, crowdsource, and we're giving permission for the fire departments and dispatches so they can move the cameras and look for fires. So this here is the Whittier fire. We just finished putting this camera up about 2 weeks before this fire. And so here we're going into nighttime, and you just watch this. So now we're going to switch to infrared. Here we go. So you'll see the light kind of change. There we go, bam, infrared does it with the light control. And this fire burnt right up to where our camera was. So we were watching this fire thinking this camera was a goner. Okay, but here, dispatch did airdrops, and they saved this tower complex. You're gonna see it's gonna come into daytime, and we're just rapid forwarding, and the fire's gonna come right down this ridge line, right towards the camera. So we were watching this live, and we were very concerned that we were gonna lose our instrument. So I'm gonna let this just run so you can see how close we came to being ashes. Okay, so it's gonna change back from infrared back to daylight. Here we go. Not a good place to be. Okay, so the Whittier fire, 18,000 plus acres burned. Okay, here it comes. We were sitting here going, oh, really? It took a lot of effort to hump that camera system and stuff up to the top of that ridge line. And here it comes, look at that. I still can't look. All right, so here, Tom Gardner, the Monte Vista battalion chief, said the live feed in high def allowed us to watch the preheating of the fuels from the fire at the bottom of the canyon and then start the brush on fire farther up the hill. We were able to watch very important fire behavior without being in danger, record it, and use it to inform others. We got an up-close look at how effective the helicopter water drops were, along with several air tanker drops over the 2 days. As I write this story, the fire last night picked up and came around the other side. We watched a hotshot crew on the hill protect it. If the IC or operations were watching, they could see the crew was safe while working on top of this hill. This provides us protection for those first responders. I'm really pleased to be part of this group and doing this. You know, Harry talked about all the accolades, and I kind of was exhausted with all the work I've been doing. But I think this is what I want to be known for. This is going to be my legacy with Graham and Frank and others, okay, Ken Smith, that we're going to leave California a little more informed about hazards than when we arrived here. So, Monte Vista, I can't explain how valuable these cameras are, okay? All right, so what we're going through, everyone that has exposure to these cameras, the first thing they say is, we want more. So for San Diego, we're gonna have about 20 in by summertime. We need about 30 is our calculation, okay? So about 30 cameras to really cover the areas. So this here shows the outline of the Cedar Fire. This is out in the Cleveland National, this is Valley Center. And here, over 280,000 acres, growing at a rate of almost 4,000 acres an hour. This is the kind of fire that caught people up north unaware. They had no warning. They met fire at the front door. We can't let that happen again. So San Diego, we learned from the '03, but almost 4 years to the day, we had another ride with fire danger, firestorm. This here, the Witch Fire. This is San Diego. You can see the smoke in the background. Here's the pattern. 240,000 acres. These are large firestorms, okay? And we're just eclipsed by the Thomas Fire, okay? 281,000 plus acres burnt, starting on December 4th. This is the outline, okay? They saved Otay here, but just devastating fire. Started here, built out, so you can see the greens are where it started, and then burnt out down in here to Montecito. You can see this from the air. The green is vegetation, the grays are towns and development. This is the burnt out area, there's the fire edge. So this is the green that you saw here where the fire is starting, and just the winds were driving it to the west, okay? Everyone that saw this fire just had never seen anything like it, okay? The winds were whipping, it was spotting embers, and just horrific. This is here, looking from Santa Paula, so over in the Ventura, Santa Clara River Valley, just looking at the hills to the north burning. This is sunrise on the second day. This is the Cal OES's camera. Here's our camera, so the one that made it, okay, the Santa Ynez camera back in action. It was like R2-D2. Okay, so let's here look at this. Okay, so here's the fire. We're looking from the west, and we're looking at the Thomas Fire just exploding. Okay, so we're looking from 6 a.m. to 2 p.m., and you can just see that this fire is just raging, and the winds are bending the smoke over. They were just evacuating and staying ahead of this, putting out spot fires and trying to keep it laterally contained. All right, so this was a horrific event, and you'll see a couple more pillows of smoke coming up, bursting up through the top here, the canopy. So this, look at the winds, look at this. This is horrific, okay? Just horrific, and as the governor noted, this is our new norm, okay? This is what we need to prepare for, okay? Because we live in a land of hazard, and we live in a land of drought, okay? So right before the landslides happened in Montecito, this map came out showing where the hazards were, high, medium, and low, okay? And all of you know what happened is these debris flows, these muddy slurries, they can transport rocks the size of Fiats, Volkswagens, SUVs. These are killers, okay? So 2 people died in the Thomas Fire. Over 20 people died in the debris flows here in Montecito. When you have mud, rocks, and water, it's a deadly combination, okay? So they were hit with what we used to call pineapple expresses, which I kind of like, but now they're called atmospheric rivers. So you come up with a new name, then, never mind. All right. So this pineapple express was pointed right at Santa Barbara region, Ventura, okay? And you know the drill. The mud just encased people, knocked their houses down, closed part of the 101, right? They took all that mud and everything and put it into the ocean. The wreckage, the loss of life was just devastating, okay? That's not landscaping, okay? That's horrific, all right? So here, they've just come out with, for the rains that we're experiencing this week, this is the new hazard model. So this is the burn area for the Thomas Fire. Here's for the Whittier Fire over here. And the red is high debris flow danger, and the yellow is moderate, So when you look at this, the people in Montecito were the San Isidro Creek here. These creeks there was nothing to hold the soils. And these debris flows, you have steep, rugged catchments, catch the rain, and shunt it quickly down to lower elevations because there's nothing to absorb it. Okay, hold the soils in place and the rocks. And they're worried now that this first big debris flow has made the slopes more susceptible for failures. They also got rid of the term voluntary. No, these poor people that had been out of their house for a long time with the Thomas fire, and it's very difficult. And so they knew there was hazards, but they didn't know the level. So Santa Barbara's gotten rid of the terminology of voluntary, and they've actually had recommended evacuation and mandatory, okay? All right, so, but if you just looked up the road at Long Conchita 2005, these debris flows are devastating, okay? So it's a consequence of the fires, another hazard we face here in California. This one was the hardest to watch, and we went up after the fires and did reconnaissance to look at the fires and the starts. They had multiple ignition points, and the fire was spotting kilometers ahead, okay? So many structures lost. 44 people lost their lives because there was no warning. It came early in the morning, and this is Santa Rosa on October 9th, okay? This is what it should have looked like. This is what a fire that's not moving at great speeds looks like, not with great winds. But the fires up here, the Tubbs fire, you drive down these roads and there's still abundant fuel to burn. So it isn't like these areas cannot reburn again, okay? Our goal for our next 30 fire cameras is to install them in Northern California. So here's a map that shows the progression of the fire. Here, this Coffee Park, Fountain Grove. All of these little red dots are destroyed structures based on satellite data. The black dots are people that aren't with us anymore, that had no warning. This is what Coffee Park used to look like. Notice here the green area to locate yourself. That's what it looks like. There was nothing but chimneys, okay? The last debris removal in Coffee Park just happened a couple weeks ago. So when we were there, they had like 30 backhoes lined up, people in hazmat suits, people sifting through their houses. And I know you say, well, it's only material things, but think of some of the things that you think of loved ones that are locked up in those. So this here, the Lilac Fire, George Murray, who's here in the audience, employee of Scripps, director of the San Onofre project, organized a lot of the seismic work, great guy. Called me on his phone. He lives on a mountain up in Oceanside. And he said, I see a fire down by the 15. So I jumped on the fire cameras. We were on it within minutes, okay? And the Lilac Fire, you're gonna see it, we caught ignition. So here we go. You can see how windy it is. All right, this is dust. This is not smoke, so get ready. These are the 3 cameras that we started tracking it with. There it is, there it's lighting off. Okay, you can see it here. So we're looking here to the south, we're looking here to the north, and we're capturing it here and here. So here, this is our stationary camera. So look at how the smoke is bent over. The Lilac Fire raced towards the coast, okay? The park right there, a lot of houses lost, okay? In Montserrat, a lot of people that didn't have insurance, okay, and can't now get reinsured because of the insurance policies of companies pulling out. Okay, so this is showing it at night here on the infrared. Okay, all right, the lilac fire. Really devastating to San Luis Downs. Okay, all right. And the horses were just running for their lives. Okay, just a real fire was bearing down on them. People were getting hurt trying to free their horses. All right, so I'm really proud of what our group is doing, and I think it's going to bring information that's critical to assess fires, marshal resources, protect people, infrastructure. But I want to leave you with a thought, because last year was a record bumper crop rain year, almost took out the Oroville Dam. Drought is part of our future, and drought makes the fuel more susceptible to large firestorms. So this plot here is snow equivalent in the Sierras. So the numbers here, okay, so there's two numbers. This is of average of here, of April 1st. Okay, so here, this is how much we have with average. So here's average, okay? And here, this number is how much we have till April 1st. And the reason we do April 1st is that's the time of year in the Sierras that we stop accumulating and we start melting. So we measure everything respect to April 1st. And what you'll notice is that here, these numbers are really low. The biggest snow year was an El Nino year in 82, 83. One of the driest years when I first got here was 76, 77, but it was eclipsed by the 2014, 2015, and look where we are now. Okay? So the snowpack, the vital storage of water for California, is at an all-time low. And you can actually go and look at the cameras that we have in Lake Tahoe. We have a series of cameras up there. There's not much snow in the Sierras, okay? So people aren't panicking, but last year's what is not normal, it's anomalous. These years around it are what are normal, okay? Drought, all right? And unfortunately, we're in the second year of a La Nina. La Nina is when the trade winds blow stronger. And research done by Kermer and his group says that in the second year of an La Nina, drought is more severe in the west and in the southern part of the country. This is the first year, and you can see it's wetter up here. There's Lake Tahoe, but look now. So it drives the storms farther north. To exacerbate this, other studies looking at sea ice and Arctic sea surface temperatures are showing that it affects the high pressure that's off our shoreline. This high pressure, what some people call this ridiculously resilient ridge of high pressure, gets set in, and we have weeks upon weeks of no weather because all of the weather is moved up north with the jet and goes into Canada, Washington, and Oregon. So these two indicators, they're not always perfect, and you want to be a skeptic, but they're suggesting that we're going to have a drought year. Okay, so normal years is when the wet tropical air, this Pineapple Express, is pointed at California. That's what we like. Okay, that's what we need. Another consequence of this is the East Coast gets frigid, and I was able to laugh at all of my colleagues at Woods Hole, okay, because I was out here enjoying 70-degree weather along the coast, and they looked like they were in the Arctic, okay? This is off Orleans, Cape Cod. Look at that. Amazing. Only in California, right? Everybody look at me. I'm not interested in you, okay? It's a great state. But we had ridiculous weather for weeks, right? Think about it. It was, the shoreline was, it felt like summer, okay? All right, and inland valleys, we topped out in the 90s. Another problem of this is the bark beetle and drought is killing our trees. We have hundreds of millions of trees at elevations about 6,000 to 8,000 feet that are dead. And studies show that these trees, the scale of present tree mortality is so large that greater potential for mass fires exists in the coming decades, driven by the amount and continuity of dry, combustible, large, woody material that could produce large, severe fires. You just have to drive up to Palomar to see this, okay? The trees aren't looking good, okay? Some people call me the Lorax. We need to save the trees, okay? So here, there's numerous websites. This is one of my favorite about being informed and have a plan for fires, okay? So we want to be prepared, just like we want to be prepared for an earthquake. You want to know your wildfire risk. You want to keep a certain distance around your house clear of fuels. Because when the fire department rolls in, the house that has clearing and hundreds of feet of defendable space, that's going to be the house that's saved. Frank Vernon, one of the colleagues on this project, lost his house in the 2003 fire. I was evacuated in the 03 and 07 fire. And my colleague Graham Kent, the back of his house was scorched, and the first responders put it out, okay? Prepare your home, have a plan. Communication is going to be difficult during these big fires on cell phones, okay? It's one of the reasons I keep a landline, even though it's got like 7,000 messages that I never listen to. You know what I'm talking to, message full. I don't care. So what I want to leave you with is this. Our group wants to build a multi-hazard network for the state of California that gives early warning to hazards, right? Fires will pay for this by knocking down the amount of money we have to put to suppress fires. It will pay for early earthquake detection. It will pay for moisture and flooding, because fires are the new norm. They're going to happen every year. It's just where. And it's how early we detect them and how we provide those brave women and men that are the first responders that go in there to fight for our infrastructure and our lives. So here, the reason we think this is going to be successful is it already has. This microwave technology, we have our own licensed frequencies. We're not going to get stepped on. We're not going to have cellular phone droppage. We'll use cell phones as a tertiary mechanism for communication, but not the primary. We have here greater bandwidth relative to cellular, okay? So widespread failure not associated with catastrophic events. So earthquakes, the Boston Marathon, cell phones went down. You didn't have communication. Scalable. So here, if we have certain failures, we have these on mountaintops. The router looks for the open shortest path first. But let's say that path is down. Then we can reroute to another mountaintop. We have resiliency. We have 15 cameras operational right now on all the mountaintops that talk to one another and talk to the command center. Okay? All right, so here with that, I'd like to take questions and thank you for your time. So the question was that the LA Times reported that the Montecito fire burned so hot that it affected the soil's capability to absorb water. And that does happen, but another thing happened also, is that there was nothing to hold the soil in place. And so the root structures, and the fire burnt so hot that it burnt the root structures in the ground. And there was nothing, and the rainfall was really rapid in a short amount of time. And so these barren hill slopes that are really steep, if you drive the 101, Ventura Highway, one of my favorite songs, if you drive the 101, you'll notice that you ascend very quickly up into the Santa Ynez Mountains. It's very steep, rugged catchments. And this is what funneled the water down the San Isidro Creek and other creeks that entombed a lot of the houses. No, so yes, the question was, did I state that SDG&E initiated all of this networking that we're seeing here and infrastructure? And no, I didn't say that. I said, so here, let me be clear. They have a command center and they've developed weather stations throughout the county. They have a group of meteorologists that work there full time. Our cameras fed new high-resolution information into their system. University of California, San Diego, Scripps Institution of Oceanography, Frank Vernon was one of the leaders, built this system called HP-REN. And that had technology, microwave technology, to bring information from the backcountry to command centers. What the upgrade was is we used these towers because they had power, they had permits, and they were already existing. We used these to put our high definition cameras on top. So we added immense value. Does that answer your question? So here, the question is, there was no warning systems for the Montecito debris flows after the fire. That map I showed you came out a day before the debris flows, but they issued a voluntary evacuation. And the people had been out of their houses for a long time. And it's really hard to go when it's voluntary, okay? So they're rethinking it. Here's the thing. There's no blame game here. We need to go forward positively and all trying to make the most informed decisions we can. No blame. Let's move forward. So the question was, would it be advantageous to put some of these cameras on balloons? And during the fire itself, you might gain some information, but you'd probably get caught up in the fire weather, and you'd probably not see your camera again. And we're on the mountaintop, so we have good coverage of a lot of areas. So I think that before we do that, one of the ideas with Falco Kuster, who's an engineer up at Cal IT Squared, also named Qualcomm, has a number of names, but he has drone technology. And one of the things we're working on is after the early detect, we could launch drones that would give us better first-hand coverage in rugged topography or areas that were shadow zones. So the question was, can we actually mitigate wildfires? Is there some positive things we can do to make the fires less of a firestorm, less of a threat? And what we've done is, in a natural setting, lightning and fires occur, and it's part of the ecosystem. And we've actually altered that pattern. And so the report I just showed you about all the dead trees, in that article, they're talking about the fact that we've allowed all of this fuel in the catchments and in the valleys and regions, so that when the fires do happen, they're more extreme. So we can do more. We had a controlled burn up in Tahoe that got away and burnt a much larger area than they thought. And people term those as overachievers. But controlled burns are an important part, and allowing the forest to go through a more natural cycle of fires and regrowth. But what we're proposing here is not going to stop fires. It's going to allow you and everyone here a better chance of not being caught at the front door. Those people in Northern California, story after story of people not knowing where the fire was, not having clear understanding of evacuation orders. We don't want that to happen again. So the camera system, we would allow people to have earlier warning allow the dispatchers to know where the fires are. Imagine that evening, okay, where fires, there were 14 different ignition sites. Imagine the calls coming into 911 and dispatch, and imagining how they take all that information and develop and marshal a plan that can save the most people and infrastructure. So we're hoping that this system provides informed decision-making so that we can try to suppress the fire earlier, but we can protect people and property. Does that answer your question?
What about
So here, some of the things we learned is that the fires up north moved so fast that they didn't burn all the fuel. And the vineyards actually protected houses and actually stopped spot firing. The leaves in the vineyards were still supple when we were up there a week later. So where a fire starts, the worst thing that happens is we get zero humidity. When we have zero humidity, my colleagues and I would say that that's the worst case scenario for ignition. Then you add to that, usually zero or low single digit humidity is accompanied by Santa Anas or offshore winds with high pressure. So to delineate, we do have boundaries like urban wildlife boundaries that we could make better, but we are watching wildfires coming from this interface into urban areas that we haven't seen before. And so we can do with these areas, these boundaries, we could probably do a better job at defensible space.
I'll be here. Please come up.
I was going to say, we've run out of time. Please help me thank Dr. Neal Driscoll for a wonderful talk.